Torpisc Design Demo. This demo is designed to help you understand how to prepare good quality Solitaire variant designs. Since the best way to design good quality Solitaire variants involves the use of Solitaire as a template to build on, I have devoted the first section of this demo to helping the viewer understand the weaknesses in Solitaire. This is necessary to be able to make an educated guess on how to change the Solitaire steps to make it stronger. Once this is done, I will show you how to generate your designs. You should also keep in mind that the Solitaire variants that this demo teaches you to design are intended to be just as solid and secure, or even stronger than Solitaire. So even if whoever is trying to decipher the messages that you send and receive through your new Solitaire variant designs knows what Solitaire variant you are using, you should still be safe and secure. Designing good quality Solitaire variants is not a requirement in being able to use Torpisc effectively, but doing so adds a new dimension to privacy and allows you to gain tempo and keep any third party from having the bandwidth to discover and prepare an effective attack against the information that is being exchanged. So it keeps you from getting fianchettoed by anyone with access to giant supercomputers and lots of supercomputing time at hand. Now I am going to go through the most important section in the introduction section of Torpisc, which is called Understanding Solitaire very briefly. In this section, the first thing that you see here is a mathematical model of Solitaire for state 3. When you have Joker A followed by 3 cards and then followed by Joker B, this is called state 3. You can develop different mathematical models for different states if you need to. So it doesn't necessarily have to be state 3, but I've done this here just to give you a picture of how Solitaire works and what potential glitches or weaknesses exist in the algorithm. The portion of this model that has been highlighted in yellow, which is the critical portion, is the count cut step. If you go down to the bias step, what you would see is the model for the bias, which basically shows that during the count cut step, when the value of the last card in the deck is equal to the position of the second joker in the deck, the first chunk of cards up to position of A-1 end up getting rearranged to their initial step before their steps. So this could potentially be a problem if, when you are trying to find a key based on the value of the first card in the deck, if the value of the first card in the deck is less than the position of Joker A-1, then the key card would fall inside this chunk of unchanged cards, and as a result the key would end up repeating itself. So this would be the first bias that this glitch would lead to, the key repeating itself. And as a result of this glitch you would get two other biases. The second one is the larger twins having a higher probability of appearance, which is discussed in the introduction section, followed by the value of the first key and the second key summing up to being 53, which is discussed in the introduction section. And then over here you have the probability reinforcement, which basically you calculate based on the size of the unchanged chunk of cards. How can we come up with Solitaire variant designs that are potentially stronger than Solitaire? Since all of the three weaknesses that I just talked about are directly tied to the same glitch, which happens during the count cut step, then what we need to do is to somehow fix that part of the design when we are designing a Solitaire variant. Now here when you are doing a design, if you look at the functions that Torpisc makes available to you, you would notice that there are 3 variants to the count card. So these 3 variants are designed to fix this problem and are made available to you by Torpisc. What the first 2 do is that they handle that situation when the value of the last card during the count card step is equal to the position of the second joker in the deck differently when that condition is met. The third variation of the count card simply ignores the count card step altogether when this happens. And I have learned by experience that the last one, which is variation 3, is actually the strongest one, even though it's the easiest to use because you don't have to do anything when that condition is met. This, on the other hand, could potentially lead to other problems because if the count card step is not executed as often anymore, this could be a weakness because the count card step is a very important step in Solitaire. So what you would most probably need to do is to add an additional step to your Solitaire variant design. But for now, what I have done is to take advantage of 2 other concepts that are very important when you are designing Solitaire variants. The first one is taking advantage of the cylinder mode to make the Solitaire variant of your choosing less random when it is executing. The second concept that you need to take advantage of in conjunction with this is to take advantage of the fact that since there is a correlation between the states and the keys in Solitaire, which has already been established in the tutorial section of Torpisc, if you can somehow change these steps in your variant design to make the states more random, then that would directly translate to a stronger variant design. So let me see if I can find that here. Here are the states for trigram, for example, when the state block length is 4. If you visualize a line such as this line and just go through it, you would notice that as the line gets closer to the first sorted key combination with the highest probability of occurrence, the value of the state sequence probabilities increases. So this establishes that fact, as can also be seen over here, even for a trigram. So now that we know that, we can take advantage of all of these 3 principles. What I'm going to do is to add a swap joker step after the first step and assign cylinder 2 to it so that it is only executed when the value of the last card in the deck during this step, during the execution of this step, is a diamond, followed by joker B plus 2, triple cut, count card variation step, and then find key. So now that we have a good design, you should also keep in mind that it's generally a good idea to come up with lots of designs that are based on partially educated guesses like this, and then develop your own design sheet and use it for the testing. This way you would give a lot of work to Torpisc to do as well, so that you don't have to carry the burden of coming up with perfect designs. If you look at this design sheet here, there are a lot of different Solitaire variants that incorporate the same concept of using the cylinder mode for any type of Torpisc function that does not directly deal with the value of a card. Good examples are swap joker, joker A or B movements, in conjunction with doing whatever you can to make the states more random, plus fixing the glitch in the count cut step. If your design takes advantage of all of these three concepts, then you are rest assured that you would be able to find a good design. Now please proceed to the Torpisc testing demo video that I have made available. Thank you.